Okay, now just so you guys know, I just learned how to graph on my iPad to make a little graph thing, and then we can finally learn how to graph together officially in 2.3 lesson. So I'm excited about today's lesson. I hope you guys are as well, as we're going to figure out all the secrets finally to graphing. If you see here, there's a few key ideas that I need you guys to write down on your notes paper. So go ahead and get your piece of lined notebook paper out and get prepared to write a few things down. Most importantly are these two concepts. Is this idea of the x-intercept of a line, is the x-coordinate at the point where the line crosses the x-axis. It occurs when y equals 0. What that means, the x-intercept, is when it crosses the x-axis. You see how they gave you a little coordinate bit over here if you draw your attention to this circled pair of points. They say a comma 0. A stands for whatever x-coordinate that is, and 0 is in the y-coordinate space. So it's whenever y equals 0, if you were to solve an equation for that, whatever number you get, that is where it crosses the x-axis. Now guess what? The next thing you need to write down is the y-intercept of a line is the y-coordinate of a point where the line crosses the y-axis. It occurs when x equals 0. So yeah, that's the exact opposite of what you just wrote down. And it's what we did in the last video, is we found this y-intercept, where in the world it crosses the y-axis. So if x is 0, then you know the line is crossing the y-axis. You see how x would be going, delete that part. And the third very important thing I need you to write down next is, it's like Star Wars, da, 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 as it scrolls down. Is this idea of slope-intercept form. Holy smokes, this is great. Welcome to the rest of math. So an equation written in the form y equals mx plus b is in the slope-intercept form. Write that definition down. And here you can define that the slope of the line is m, or you'd even say slope equals m if you don't want to write very much down, and y-intercept, or y-int, as we'll start to get used to it, equals b. So we know that whatever number is right next to x, is multiplying against x, is the slope. Whatever number is being added or subtracted to x is the y-intercept. We did this the last time. Now we're looking at the nitty-gritty of the math. The first part here is pretty easy. All they want us to do is find the slope and y-intercept of the graph of each linear equation. I don't know about you, but if I don't have to graph something, then I don't want to graph something. If I get to graph something, well then I'm overly excited to graph it. But here they say, no, you don't get to graph this. I'm sorry. They just want to find the slope and the y-intercept. So the slope, if you remember, is whatever number is right next to x. In this case, it's that green -4, whatever number is being multiplied against x. And you see how they moved that negative for the 2 close to -2, so it's like adding a negative number or subtracting, how those are the same thing. Because they want you to have everything that's next to that 2 as a part of the y-intercept. So the slope is -4 and the y-intercept is -2. They had that whole thing on there. Now b, this one's a little bit different in that they don't give you the equation nicely like they do, like they did in letter A. We have to get the equation into slope-intercept form. If you guys see at the top of your paper again, it has to look just like this, meaning y is by itself, and there's a number multiplying against x, and then plus or minus some other number. No funny business. You can't have anything next to y, and you can't have any too much funny business on the other side either. So in order to get this looking like we want, looking like slope-intercept form, we need to get y by itself. So they added 5 to both sides. See that? And they ended up with y equals 3 halves x, then plus 5, because they did that to both sides. Now if we were to look at where our slope-intercept is, you'll see that, or what our slope and y-intercept is. This is the number that's being multiplied against x, and here is the number that's being added or subtracted. So your slope is 3 halves, and your y-intercept is positive 5. Little on your own is go ahead and just identify and write down. All you have to do, you don't even really have to show any work, you just need to identify the correct slope and y-intercept. You may want to write down the equation on your piece of paper so you can correctly dissect which one is the slope, which one is the y-intercept. Hint, hint on number 2, make sure you add 1 to both sides and then get your slope and your y-intercept. Remember, y has to be by itself. So can you hear me at all, Lou? Can you hear me at all? How's it sound? And like full disclosure in the studio, Lacey is in the room while I record this. She is not doing math, but she is here listening and approving to this message as I speak it. Lacey approves of math. You can write that on your paper if you want. In fact, I'll give you an extra credit point if you write Lacey approves of math. It's a little secret bonus Easter egg. Alright, graphing a linear equation in slope-intercept form. We graphed a little before, and now we're going to do it again. They give us the nice equation here. They say graph y equals negative 3x plus 3 and identify the x-intercept. Now it's easy to identify the y-intercept and the slope. To get the x-intercept is a little bit trickier. So before we graph anything, we always first find the slope and the y-intercept. You see that it's already in slope-intercept form. Y equals mx plus b. See how it's in that form already. And they've identified the slope and they've identified the y-intercept. So then they plotted the easy point. They know where it's going to cross the x-axis, or sorry, the y-axis. It's going to cross right at 0, 3. And then they gave it a negative 3 slope, meaning over 1, down negative 3, and plotted another point. And then drew a line through all that. A little rise over run. And if you see here, the line actually crosses the x-axis, meaning x, redo, meaning when what is x when y is 0? And looks like when y is 0 means there's no up or down, x is 1. So the y-intercept, or so the line crosses the x-axis at 0, 1, and the x-intercept then equals 1. Now before we go on, what I want to do is do the on your owns 3 and 4 so we don't get too far ahead of ourselves. First thing is let's graph this linear equation, like they say, and find the x-intercept. Dun, dun, dun. I'm going to switch to my graphing screen. Hey, I'm back on the graphing screen. And let's go ahead and do the three things that the book did. First they have the equation there written for them, but let's write it out. So I like to write y equals x minus 4. Next they say find the slope in the y-intercept. Now there's no number next to x, or there's always a secret 1 that's being multiplied there. So the slope is 1. Say m equals 1. Now next they say find the y-intercept. Well, the y-intercept's whatever number is being multiplied or redo. The y-intercept is whatever number is being added or subtracted in this equation. So 2x, which is -4. So y dash int equals -4. All right. What that does is it gives us a place to start when we graph. So let's go to y -4. Sorry, 0, -4, over 0, down -4. And then using a slope of 1, let's do some graphing. Over 1, up 1, over 1, up 1, over 1, up 1. See where we're going here. Now, when we're trying to find these x-intercepts and y-intercepts, it's good to graph it until we cross the actual axis so we can see. I'm going to get my little line tool. And let's line my line up with all of my dots. And we see here, actually, that this line crosses the x-axis when x is 4 and when y is 0. So our x-intercept, or x dash int, equals 4. Let's do the next one together as well. So let's first write our equation down. Y equals -1/2 x plus 1. This one has a little bit more interesting of a slope. Is it in y-intercept? Redo. Is it in slope-intercept form? You betcha. And our slope, if we identify it, is -1/2, and our y-intercept is +1. So let's go to where our line crosses the y-axis at 0, -1. We'll draw a dot, and then we'll use our slope to draw our dots after that. Now, since the line is negative, or a -1/2 slope, that means it's going to go down, and our rise is 1, and our run is 2. So I like to go over 2, 1, 2, down 1, over 2, down 1, over 2, down 1. And let's go the opposite direction. So backwards 2, up 1, backwards 2, up 1. See how I have all these nice dots? The more dots you have, the more accurate you can actually be. Go ahead and get my line tool. We'll line up the line. It's like you getting your straight edge. You'll see a perfectly drawn line. So the big question is, where does this cross the x-axis? And if you look here, when x is 2, y appears to be 0. That means that's when it crosses the x-axis, or your x-intercept will be 2. X-int equals 2. So I'll need both a graph and the x-intercept written down for your paper. So want to know a little tip? Is you can actually check your x-intercept by substituting y equals 0 in the equation, just like it says here. So instead of graphing it, you can actually find the y-intercept by just putting 0 in for y. You see how y changed to 0, and then they just solved. They subtracted 3 from both sides. 0 minus 3 is just negative 3 equals negative 3x. Then they divided both sides by negative 3. And x actually equals 1. Well, that's the same thing they got here in the example. What? Bonus tips. So that makes it so you know you're exactly right. Doing the algebra of things is always going to be more accurate than graphing. Graphing just helps us see what's going on. So let's see what's going on. I'm not sure if any of you guys have ever had to take the Orcas Island taxi before, but I know taxis can get kind of expensive. So how do they charge what they're doing? Let's figure it out. You can graph this and you can see this data. They say the cost in y, redo. They say the cost y in dollars of taking a taxi X amount of miles is y, remember that's your cost, equals 2.5x plus 2. Now they want to graph the equation so we can see it, and then we want to interpret it. Figure out what do these points even mean and why are they important. They are important, just so you know. Now the slope of this line is 2.5, or that's like saying 2.5 or 5 halves. It's like if you had 2.5 pizzas, you're like, if we have cut all these in half, how many giant half pieces of pizza do we have? Oh, you have 5 of them. Now they'd like redo. Now we're going to use that slope and y-intercept to graph it. So the y-intercept, if you saw, was positive 2. So we can, that's where they started with that dot. Then they used the slope 5 over 2. So I like to go over 2, 1, 2, and then rise 1, 2, 3, 4, 5, and plot to their next point. So if you see here, you'll realize that the slope is 2.5. So the cost per mile that they go, remember x is miles, is $2.50. So, but this y-intercept is 2, meaning that before you went any miles, when you went 0 miles, it still cost you $2. So whatever y equals is how much you're paying. Whatever x equals is how far you went. For the last on your own example, they want to change things up a little bit. They said in example 3, the cost y in dollars of taking a different taxi, x miles, is, they have a different taxi's equation here, is y equals 2x plus 1.5. All they want you to do is to interpret the y-intercept and the slope. So use the example above to interpret how much it costs you per mile and how much it costs you when you have gone 0 miles. The second you get in that taxi, you already owe them that much money. I will see you in class. I hope you enjoyed our adventure in graphing land. Sure. 20 minutes, not bad.